All right, so Mr. Samuel actually covered a good amount of the beginning of this, where we're talking about integrals of products of sines and cosines, products of tangents and secants, products of cotangents and cosecants. And as you know, these are our trig partners. Sine and cosine go together, tangent and secant go together, and cotangent and cosecant go together. We always structure our integrals so that that's the way that they appear. So he went over the perfect derivative, the integral of secant squared and cosecant squared. Those are easy. He talked about important trig formulas. These you have to know. There's no way of getting around it. And you have to know them. And when you walk into
he went in there.
Okay, you have to know them all, because if you go into a test and you open up the thing and you start looking for your formulas, the rest of the stuff flies out of your head. Okay, so integrals of sine squared and cosine squared, that should be a U. Go back, I don't know where that happened. Where was that?
Can you, okay, thank you. Can you go back real quick so I can write down the formulas?
Yes. And we're going to use those a lot today.
Thank you.
You're welcome. Okay, so to integrate, he showed you how to integrate these 4 problems. Okay, and so then we got to integrals of, let me see, where am I? Yeah. Okay, so he showed you how to do that, and then integrals of products and sines and cosines. Okay, so for the products of sines and cosines, the first case is the easiest case. That's where at least one of M or N is an odd positive integer. This case by far is the much easier of the 2. This case, you may have something that looks like, for example, the integral of the sine 4x cosine cubed x dx. Okay, so as you can see, the cosine cubed, that's odd. So you want to pull that off. So I'm going to get the integral of the sine to the 4th of x, the cosine squared of x, and then the cosine of x dx. And once I do that, then all the other cosines in the problem have to go. So when I pull off one cosine, I now have to switch out all my cosines. So now this becomes the integral to the sine to the 4th of x. And for the cosine squared, I'm going to write 1 minus sine squared of x. And then I have the cosine of x dx. And so now the cosine of x dx is the only cosine in the problem. That's what I want, because I pulled it off and threw away all the other cosines by changing them to sines. So now I can let u equal to the sine of x, du is cosine x dx. Well, how perfect is that? So this is the integral. Sine to the 4th becomes u to the 4th, 1 minus u squared, and cosine x dx becomes du. Perfect, beautiful transformation. So this is the integral of u to the 4th minus u to the 6th du. I need just a wee bit more space. I did record to the cloud, right? Yeah. So this becomes the integral. No, it does not. Now I integrate it, find the antiderivative. So the antiderivative is 1 over 5 u to the 5th minus 1 over 7 u to the 7th plus a constant. And so now I have an answer because I can plug my u back in. And so I get the integral of the sine to the 4th x cosine cubed x dx just becomes 1 over 5. U was the sine to the 5th of x minus 1 over 7, the sine to the 7th of x plus a constant. Okay. So those are the easy ones. Just pop one of those off. Okay, so he went over that one and gave an example. So the more difficult ones are when both of them are even. So that means you can have, let's see, integral, oh, I want that black. Did I have a 1 next to that? No, I don't need one yet. The integral, the sine of 3x, sine squared of 3x cosine cubed of 3x dx. Now these are the hard ones. Okay, even if I don't have, if I just have sine squared or sine to the 4th, I know he did one of those. These are the difficult ones. And the reason why is because we have to make use of that other formula up there. So for this one, we have to make use of the formulas, the double angle formula. So we have the integral, so we have sine squared of x is equal to 1/2 times 1 plus, nope, 1 minus the cosine of 2x, and the cosine squared of x is 1/2 times 1 plus the cosine of 2x. Now, the reason why this is so difficult is because I need to do the double angle formula. So sine squared of 3x becomes 1/2. Oh, this is supposed to be a 4. Otherwise, the problem is easy.
I have a quick question. We just used the, you chose the formulas based on what's given to us in the problem. So if since it's
Yes. So whenever both of the power, whenever one of the powers is odd, you pull that one off. You pull one off. See how it was cosine cubed and I wrote it as cosine squared times cosine? I pulled the cosine out. So once I take from it, I need to get rid of all the other cosines in the problem. So I pulled the cosine out and then switched over the cosine squared as 1 minus sine squared. So here I use cosine squared of x was 1 minus sine squared of x. So I use that formula. But if they both are even powers, so you see I have squared and to the 4th, so they're both even powers, squared and to the 4th, I have to use these formulas, double angle formula up top. So now in the place of 2x, I have the sine squared of 3x. So that is 1/2 times 1 minus the cosine of 6x. And then this one is actually this thing right here is actually the cosine squared of 3x squared. So therefore, I got to square that. So I get 1 over 4 times 1 plus the cosine of 6x squared dx. So now that's what I have to integrate. So as I substituted here, I'll just add in one more line. So here I used sine squared of 3x is equal to 1/2 times 1 minus the cosine of 6x. And I used the cosine squared of 3x is 1/2 times 1 plus the cosine of 6x. Notice I didn't use this form of sine squared or cosine squared. This form of sine squared or cosine squared I used to replace it out. This one I use when they're both even. So when they're both even, I have to use the double angle formula. So in the place of the cosine to the 4th of 3x, integral of the sine squared of 3x. And then this is the cosine squared of 3x squared dx, because it's to the 4th power. So therefore, I put in the sine squared of 3x was 1/2, 1 minus the cosine of 6x, and the cosine squared of 3x, the 1/2 got squared, gave me 1/4, and I get 1 plus the cosine of 6x squared dx. And this is a hairy, scary problem. I know he went through one like this. You can pull out the 1/8, and this is 1 minus the cosine of 6x times 1 plus 2, the cosine of 6x plus the cosine cubed, cosine squared of 6x dx. So this now becomes 1/8, the integral. I'm going to get 1 plus 2 cosine 6x plus cosine squared of 6x. Then I'm going to get minus the cosine of 6x. I'm going to get minus 2 the cosine squared of 6x. And then I'm going to get minus cosine cubed of 6x dx. And then I get 1/8. I have 1. Oh, I forgot my integral sign. Dun, 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 dun. Okay, so now I get 1, 2 cosine, I get plus cosine of 6x. I get minus cosine squared of 6x. Minus cosine cubed of 6x dx. And then I got to do something special for this integral. And then I got to do something else special for this integral. So for this integral, I'm going to pull off a cosine of 6x and then switch, because that's an odd power. So that one's an odd power. So I'll go back and do it the first way. And this one's an even power. So I'm going to have to replace it with 1/2 times 1 plus the cosine of 12x. So this case is very long. And it takes up a great amount of time that I don't have right now to go into detail for finishing that. Okay. All righty, that should be secant. All right. So we do integrals of products of tangents and secants. They are lifelong partners. So everything you do with tangents and secants will be in terms of each other. They are lifelong partners. All right, so we already know the integral of this cosine of x. What am I doing? Is the sine of x dx. And the integral of the sine of x dx is minus cosine of x. And this is not a dx, this is a plus c. Those we know. We even found the integral of tangent of x. So the integral, I don't know if you remember, the integral of tangent of x dx, we wrote it as the integral of the sine of x over the cosine of x dx. And we let u equal cosine x and du equal negative sine of x dx. So the sine of x dx was negative du. So we let that happen. And so then we switched this to the integral. Sine of x dx was negative du. Cosine is u. So we got the log of the absolute value of u plus a constant, which we wrote as the log, oh, and it's negative. So we got negative the log of absolute value of the cosine of x plus c. This is review. I did this one already. So this becomes the log of the absolute value of the cosine of x raised to the negative 1 power plus a constant. So that gave us secant. So we got the integral of the tangent of x dx became the log of the absolute value of the secant of x plus a constant. So we did that. And so then we knew how to integrate tangent. And we said anything you do for tangent, you can do for cotangent, except the negatives will affect you. So we did the integral of cotangent. And its lifelong buddy is cosecant. So this is negative the log of the cosecant of x plus a constant. All righty, so we got that. So the only one we haven't integrated is secant and cosecant. All right, and they require a little bit of ingenuity. So the integral of the secant of x dx requires us to manipulate our formula by using a product of 1 in the form of secant x plus tangent x over secant x plus tangent x. That quantity is 1. And so I can multiply any integral I want by 1 and not change it. So this conveniently becomes the integral. In the numerator, I get secant squared x plus secant x tangent x. They should sound familiar to you. It's just saying, I know what they are. And then I have secant x plus tangent x in the denominator. All right. So for this problem, I let u equal secant x plus tangent x. And then du is secant x tangent x plus secant squared x dx. And look how cool that is, guys. This is right here. So just by multiplying by that term, I can get my du as I need it to be. So this is the integral of du over u, which is the log of the absolute value of u plus a constant. So therefore, I have my formula. That is the integral of the secant of x dx turns out to be the log of the absolute value of the secant of x plus the tangent of x plus a constant. And similarly, the integral of the cosecant of x dx is negative the log of the absolute value of the cosecant of x plus the cotangent of x plus a constant. So now we know how to integrate all of the trig functions to the first power. We did it. We have them all. Okay, any questions?